Hello, welcome to Picture Me Coding with Eric Aker and Mike Moll. Hi, Mike.
Hey there. About a year ago, maybe 2 years ago, Eric and I were trying to figure out how to set CPU limits and memory limits on our Kubernetes cluster, and we were struggling with it a little bit. And so we're trying to figure out the scheduler, and I came across this project called SimCube, which I thought was really cool. I thought, hey, I wish I had thought of that. SimCube comes out of an organization called Applied Computing Research Labs. And our guest today is the founder of Applied Computing Research Labs, David Morrison. He recently wrote an article in ACMQ called Simulation, an Underutilized Tool in Distributed Systems, which we really liked a lot. It's really well written. So we asked him to come on the show today to talk about that article and his work at Applied Computing Research Labs. Could you tell us a little bit about your background, David?
Sure. Thanks for having me on the show. Super excited to be here. So my background actually is a little bit roundabout to distributed systems. I did my PhD work in a field called operations research, which is kind of the intersection of applied math and theoretical computer science. So it's looking at a lot of like scheduling and optimization type problems. And so my thesis work was actually looking at graph coloring, which is this, very classical theoretical computer science problem. When I left academia, I needed to go get a real job, and I had a friend who worked at Yelp, and he's like, "Hey, our distributed systems team wants to save money on their AWS bill, and it sounds like your background could maybe help out with that." So I joined that team and didn't know anything about distributed systems. So it was very much a trial by fire, but spent a whole bunch of time dealing with Apache Mesos. And then we eventually transitioned from Mesos to Kubernetes and still kept sort of my scheduling and auto-scaling bent and interest, but applied to distributed systems. And so really that was my first introduction to the field and learned a lot. I've been doing that for about 10 years now. First at Yelp, then I was at Airbnb for a few years, and now I'm kind of on my own. So,
as you know, part of our format is that we talk about music that we're listening to. Anything you've been listening to you'd like to talk about?
Yeah, so you probably know this about me if you know me, but I'm a kind of a huge Swiftie. So I actually went to her Eras tour in LA last year, which was just a really, fun and joyful experience. So
I've heard those productions are just mind-blowing with
it was amazing.
Staging and costumes and
Yeah.
everything. I've heard that it's you can't even, you got to be there.
Was it difficult to get tickets? I've heard that's a pretty hard show to get into.
I had a friend who had a spare ticket that I was able to get. I tried to go through the whole lottery system and get tickets on my own, and it did not happen. But I kind of lucked out. So,
well, that's excellent. One of my son's girlfriends, who's a postdoc at UCLA, is also a huge Swiftie, so she'll be super happy that we finally mentioned her on the show.
There you go.
You already talked about how you kind of transitioned from your PhD work into distributed systems. One thing that you did at Yelp was you built something called ClusterMan.
Mm-hmm.
Could you maybe talk about that a little bit? It sounds like that maybe was your first endeavor into doing simulation for distributed systems.
Yeah. So at Yelp, we were running a bunch, at the time it was a Apache Mesos, and we had a whole bunch of different clusters, and we're trying to figure out how to scale them up and down better. So ClusterMan was my sort of idea of how can we write a cluster autoscaler that sort of understands the workloads that are running on it and is able to sort of, scale up when we expect to have more traffic and scale down when we don't. Yelp, like a lot of other companies, have very sort of cyclic traffic patterns. So we're able to use we were attempting to use some of the signals about time of day and data that we had around our customers to scale. And then part of that project, like you mentioned, was wanting to build a simulator as well. It's easy to handle spikes in traffic. You just scale up your cluster to the maximum whenever you see a tiny little burst. but that's not going to be cost effective. And on the other side, it's really easy to save money. You just never scale up, but that's going to, cause an incident or an outage. And so trying to understand like where that sweet spot is really requires a lot of experimentation. So the simulator that we built as a part of ClusterMan was an attempt to provide a environment that we could experiment without necessarily experimenting in prod.
This is kind of a personal interest, but is there like a forecasting aspect to that? Like, do you look at traffic patterns and try to predict what's coming based on what you know from history?
We actually tried to do that. It didn't end up working out super well. I think that there could be applications where you want to do the forecasting, but what we found is actually better is just being able to respond very, very quickly. If you see an event and then you're able to scale up like quickly, that generally worked better than trying to predict what was going to happen.
Do you have kind of a order of magnitude for how quickly we're talking? We're talking seconds or minutes or?
Our goal when I was there, and this might have changed, but when I was there, our goal was around a minute to get new machines coming up.
You had this post about ClusterMan when you were at Yelp, and I liked reading that post. You wrote the problem with autoscaling is that it's invisible when it works, catastrophic when it doesn't, and nearly impossible to test, except on production workloads. And I related to this, but it sounded to me like this broader distillation of what it's like just keeping infrastructure healthy. It's like,
yes.
If it's healthy for months at a time, no one comes to you and says, thanks, absolutely nothing happened. And when it goes wrong, everybody complains.
Yes.
It's like the kind of core of infrastructure there.
Yes.
In your work, you've talked about statistical analysis. Did you start introducing more statistical analysis when you were working on ClusterMan, or did that come along more later? And did you find that it was a thing that the teams you were working with weren't used to applying those types of methods to analyze what they were doing?
Yeah. When I was at Yelp, I actually started this. It was kind of a reading group called Infrastructure Analytics, where was trying to sort of bring in a lot more of this statistical modeling mindset to folks who were there. And it was generally really well received. What I've found is that working with folks with an infrastructure background or a DevOps background, they really want to be doing these types of statistical analyses, or like even you hear like data driven from like engineering leadership a lot. But folks just aren't necessarily sure what the tools are out there to be able to do this effectively. I wasn't the only one, but we had like a reading group where we were reading papers in the field and trying to figure out sort of how we can apply these things to our distributed systems.
So after Yelp, you started to work on SimCube, or did you start working on SimCube while you were still at Yelp?
So I went from Yelp to Airbnb and was doing a lot of the same stuff at Airbnb. So it was a lot of auto-scaling. At Airbnb, I started contributing to the Kubernetes cluster autoscaler, and I'm actually an approver for part of that code, which is kind of cool.
So if we have complaints, we'll just call you up and go, hey.
Yeah, exactly.
I promise we won't do that.
Yeah. But yeah, Airbnb was a lot more of the same, like auto-scaling, cost optimization, how do we save money on our bill? And then SimCube really didn't start until I left Airbnb and started ACRL.
I sort of mentioned in the introduction that I think we came across SimCube first when we were trying to figure out the Kubernetes scheduler. Mm-hmm. You also say in your article that part of your motivation for SimCube was to try to figure out the scheduler. Do you sort of feel like you accomplished that, or is it still a learning experience?
I mean, the Kubernetes scheduler is massive. So I would say I think I have a better understanding of it than a lot of people, but there's still like huge portions of it that are kind of opaque to me. So
you're not gonna explain it to us here on the podcast.
I mean, I guess I could, but we might derail the conversation a bit.
I really enjoyed reading this article that you published, SimCube Part 1, Why Do We Need a Simulator? Because I honestly, when I thought, we're going to simulate Kubernetes scheduling, I did think, okay, is that going to help me? How is that going to help me? It sounds like a very cool project. But you had this passage in there about, you write distributed systems, debugging distributed systems sucks. And I was like, it really resonated with me. I'm just going to read this little chunk that you wrote. You wrote, because we don't understand the behavior when something breaks, and it will break, we don't understand how to fix it. So we make a guess, we apply a band-aid, we change some parameter to fix the immediate problem, but then 2 months later, something else breaks, we apply another band-aid, then another. And then 3 years later, your system's coated in band-aids that themselves interact in unpredictable ways until you can't even fix your existing problem without creating a new one. I really liked that passage. It really resonated with me. And I made this comment to Mike a couple weeks ago that there's a dirty secret. We do fix things without really understanding the root cause, and we move on. And there's this kind of pressure to get them working, to get the business operational again, and
Mm-hmm.
to continue contributing, to continue engineering work.
Mm-hmm.
Did you have any specific experiences or examples where you remember this type of thing happening, where you ended up with a real big ball of complexity that was hard to unwind after a while?
I mean, yes. Like you said, I feel like that's kind of the nature of infrastructure and distributed systems work. There's a lot of top-down pressure to build new features and keep the business moving, because none of these companies, like distributed systems is not their like product necessarily, unless you're working at an infrastructure company, but like that's not their product. It's just something that helps support the product and keep it going.
Mm-hmm.
And so I've talked with a lot of different folks, where not just places I've worked, but elsewhere, where it's like, your distributed platform is just a massive ball of tech debt. And it's very difficult to untangle. And I've definitely had experiences where it's like, oh, this should be an easy change. I'll just go in and make it. And then it takes down the entire system. In some places, there's even a bit of like learned helplessness of like, we can't touch anything because as soon as we touch something, then it's going to cause an incident. And we've had too many incidents in the last quarter, and now the CEO is looking at us funny. So, I had you asked about like specific incident. Like there was one where something went wrong. I don't even remember exactly what happened, but it caused all of the traffic to our clusters to stop. And so like the initial cause for the incident like was unrelated to distributed systems. It was just like something went wrong and we weren't getting any traffic. We have all of these systems in place that are like, oh, there's no traffic coming in, so we can scale everything down. And when that's working normally, it's a really good cost savings measure. But this was the middle of the day, and we were expecting that the incident was going to get resolved. And as soon as the incident would get resolved, then we'd get this huge burst of traffic because everyone's hitting the website over and over and over again. And so I went in and was like, okay, we're going to, just manually scale everything back up so that when the root cause is fixed, when the incident's mitigated and we get this big burst of traffic, we can handle it. What I didn't realize is that somebody else had gone in and made a change to shift all of our preferred instance types, our preferred EC2 instance types, to a different set of machines. And so then I scaled up the wrong set of machines, and then everything, like it prolonged the outage because everything was on this like suboptimal set of machines, and we had to like then go and reshift everything back over to the new modern set. And so it's just these like compounding, like there's technical issues, there's communications issues, and there's just like all of these things that kind of compound that make it a very, very difficult domain to reason about.
Mm-hmm. It's almost like synergistic complexity or something.
Mm-hmm.
Like
Mm-hmm.
it's much bigger. In this same article, Why Do We Need a Simulator? You write that distributed systems have emergent behavior. Other people have said the same. But the thing I found interesting in your ACMQ article about SimCube is you describe at the beginning, with the rise of Kubernetes, the popularity of Kubernetes, suddenly a lot more people are doing distributed systems, whether they want to or not.
Mm-hmm.
Would you give an organization, maybe a small or medium-sized organization, they want to adopt Kubernetes, it's very popular. Do you have any cautions or concerns you raise when you hear these types of people moving in that direction?
Mm-hmm. There's a lot of good things that Kubernetes brings to the table. It's also, the ability to sort of schedule and scale and sort of the whole declarative nature of Kubernetes. All of these are really, really good things. If you're running, I was talking to somebody a year or so ago, and they're like, yeah, we have a 5-node Kubernetes cluster that's running 2 applications. And I'm like, is that actually really necessary for you at this point in time? And maybe it was like I wasn't involved in their organization.
Maybe they had big plans.
Oh, sure. I think it's important to question like when you need some of the functionality that Kubernetes provides. And then I think it's also important to question like what specific functionality you require and only expose that functionality to your users. This is something I think we did really well at Yelp is we built, this is all open source. You can actually go look at Yelp's Pasta. It's their platform as a service product. It's the intermediate layer between Kubernetes and the developers at Yelp. And it exposes a really specific set of functionality. And it does it in a way that Yelp product developers don't have to understand Kubernetes YAML, which is great.
So they don't start first day and you hand them over. You go, here's your kubectl.
Right. No, not at all. I've talked with other organizations.
That's what we do at my organization.
Oh, yeah. I've talked with a lot of other companies that do that, and it's like now all of a sudden your product developers have to understand really arcane things about distributed systems, and they end up using features in a way that maybe they weren't intended or are suboptimal. So I think like really limiting the functionality to what you actually need and then sort of like gradually opening up new use cases as you discover them is probably the way to go.
Okay. It's not necessarily that if you're small or medium size that it doesn't make sense. It's what's your actual use case? How many things are you going to deploy? What are the things you're looking to get? I mentioned this Oliver Gould claim. Oliver Gould, you might not know who he is, but he's a person who created Linkerd. He posted on Blue Sky the other day. This is a quote: "I'm convinced that people adopt Kubernetes as a way to punt on thinking about resource allocation." Now, I don't have an opinion on that myself, but it could certainly be true. Have you had this? Have you had this same idea occur to you? Have you ever heard anybody mention something similar? Do you think there's validity to what he's saying?
I definitely think there is. Back in the 90s, I mean, this was before even I was doing software, but like back in the 90s, capacity planning was a huge part of what you did as an infrastructure person. Like, how big do our data centers need to be? And what applications are going to be running on them? And, oh, you want to spin up a new application? Well, we need to provision hardware for that. And Kubernetes and the cloud have made it so that you don't necessarily have to do that. And I think that maybe there's some skill there that's been sort of lost as an industry.
Interesting.
We were just talking about this in a recent episode of my experiences at Yahoo, early 2000s, where that was a large part of my job. So
yeah, and Mike actually went to one of the founders of Yahoo and had to beg him for a server for a service that he was working on.
Oh no.
Yeah, that was embarrassing to ask a guy who's worth $2 billion if I can have another 5 servers. But
yep.
In your article, one of the detailed examples you give is this comparison between KCA and Carpenter. You want to just to sort of discuss what you did there and how you use the simulation to figure stuff out?
Sure. Yeah, so KCA, Kubernetes Cluster Autoscaler, and Carpenter are two, I don't know if I want to say they're competing. They're two different alternatives for how you can do autoscaling at a cluster level for your Kubernetes cluster. The cluster autoscaler was sort of the initial project. It was built way back in the Kubernetes 1.0 era. And so it's been around for a long time and is really battle tested and battle hardened. But it was developed when we didn't necessarily know best practices for how to write Kubernetes operators and controllers. And so there's a bunch of design decisions baked in that, I think if we were to rewrite it today, probably wouldn't have been made or would have been made differently. Carpenter is a product that was developed by AWS more recently in, I think, 2018 or around then, and really uses a lot of these sort of modern Kubernetes development styles and techniques. So it's got a number of independent controllers that have reconcile loops that are watching for Kubernetes resources and making changes as it sees changes to these resources. The popular narrative, if you go to KubeCon every year, there's a talk about how I switched from Cluster Autoscaler to Carpenter and it's so much faster and better. And so I really wanted to sort of identify, like, are these claims sort of backed up by the data or not? And so what I did is spun up a small Kubernetes cluster, ran, there's this application called Death Star Bench, which is used in a lot of the research literature for benchmarking microservice-oriented applications. I spun up a copy of that, induced a bunch of load, and then was able to, record using SimCube the behavior of Death Star Bench, and then replay that in a simulated environment. And had two different environments, one running cluster autoscaler and one running Carpenter, and was sort of able to watch the behavior of both of these autoscalers as this simulation occurred. And so then was able to collect a lot of really fine-grained data about, like, where does cluster autoscaler actually do really well? Where does Carpenter actually do really well? And, got a lot of really cool graphs and charts and things.
Yeah, I actually really appreciated that part of your article because I have heard the popular narrative that you told, like, oh, Carpenter is latest and greatest. If you're going to do something with cluster autoscaling, try Carpenter. And in your article, I realized, oh, it's like they're doing sort of different things. They're not necessarily one for one equally comparable.
Right.
Now, one word you use there that I really, and this is, I think, the curiosity I had when I first approached SimCube, and the thing I still think about when I think about if I want to use this to simulate my projects or work on or test my projects, is you talked about the behavior of the application and simulating the cluster for that behavior. Can you give us a little more detail about what you mean when you use Death Star Bench and you're looking at its behavior? There's some signals in there, probably. Like, what are we talking about when we talk about the behavior of the app?
Sure. So SimCube is really focused on understanding your cluster's control plane. What is the scheduler doing? What is the autoscaler doing? If you've written like a custom controller or an operator or something like that, how does that respond to changing conditions? So the way that it works is all of your application code, so Death Star Bench in this case, is fake. So I ran a real Death Star Bench and collected data about what deployments and objects and things were getting created, but then in my simulated environment, all of that stuff is faked out. And so I can really focus in on, like, when does the cluster scale up in response to increased number of pods, or what specific nodes do these pods actually get scheduled on? So one of the differences between cluster autoscaler and Carpenter that I was able to really narrow in on is, out of the box, cluster autoscaler just kind of spins up a random set of nodes. And so I ran a whole bunch of different copies of this simulation, and every time cluster autoscaler did something a little bit different. Whereas Carpenter is really focused in on sort of the cost optimization side of things. And so it's much more deterministic about the choices that it makes when it scales up. And so that's the type of behavior that I'm really looking at.
So for the benefit of people listening, that there are sort of two parts to SimCube, I think. There's a tracer part that you put in your production cluster that collects traces. And then there's a sort of simulation driver part that takes that trace and runs it against the simulation environment.
Right.
In your ACM article, you make a mention that see, how do you put it? The question of what detailed enough means is left as an exercise for the reader. I have to confess that this is kind of like a math book for me, where I didn't know how to fill in the blanks. So,
but this is something that, like, Mike and I have sweated about. Detailed enough. Like, I want to know what the app is doing. What is detailed enough?
Right. So this is actually something that I've had numerous debates with people about at both Yelp and Airbnb and elsewhere. As an infrastructure team, you want to understand, like, at a sub-second level, like, what's happening. And then your observability team comes to you and says, you can't collect metrics that much because that's going to cost several $billion. And so trying to understand, like, can we collect, is 15 seconds okay? Is 30 seconds okay? And then you also made a point somewhere that, a lot of these sort of CPU level things are happening at a sub-second sort of granularity. And can we even measure that? And so your question is, like, what is detailed enough? Well, it really depends on your application. It may be the case that 15 or 30 seconds is fine if you're trying to get like broader trends, or you're trying to do like a big picture analysis of like what happens over the course of weeks or months. Well, you really don't need to be collecting data every second. However, if you're really trying to narrow in on like what went wrong in this 5-minute window, then maybe you do need to be collecting as much data as you can during that period of time.
Just to follow that, I often have this frustration where it's like in the famous CSI meme where it's like enhance, enhance, enhance. That's what I
Yes.
that's what I want with the metrics, because what will often happen is people are running these apps. They have like HTTP requests that fail. Those timeouts are typically by default they're like a 10-second timeout, and there'll be like a couple second window where resources were constrained,
Mm-hmm.
and that thing just sucked. And
Yep.
you can't see that. We have a
Yep.
30-second interval on our metrics. You can't see it. And people are like, well, everything looks fine. And there's this
Right.
frustrating invisibility, but it doesn't matter how detailed we go. Well, maybe it does, but it feels like we'll never achieve perfect visibility.
I think that's true. I actually have this when talking with folks about simulation and SimCube. People are like, but how do you know that your simulation is actually simulating the right stuff? And I'm like, well, you don't. The
Mm-hmm.
whole point of simulation is that the real world is too hard to reason about. And so you're deliberately throwing away information. And so the name of the game is not never throw away any information. It's like, what's the information you can throw away without impacting your analysis?
You talk about this a bit in your ACM article, but one thing that is kind of surprises me about our industry is that almost every other engineering field has embraced simulation in some way or another, but it seems to be still pretty unusual in software, even
Mm-hmm.
distributed systems. Do you have any? I know you talk about it in your article, but do you have any like feelings about why that is? Why our field seems resistant to it?
Yeah, actually, one of the quotes I said in the article that I still think about a lot is if you're building a bridge, like nobody would build a bridge without running a computer simulation of it first. Nobody's going to fly an airplane without running simulations to see how it performs under different circumstances. But in infrastructure, like computer infrastructure, it seems as though people are pretty comfortable just throwing stuff out and seeing what happens. I think some of that is like a cost benefit analysis, where if you build a bridge and the bridge breaks, the costs of that are astronomical. Like people could die, people could, you know, and just even the materials are very expensive, and now everybody's impacted because they have to drive a different way or something like that. Nobody is going to die because they couldn't get a Yelp recommendation. And so I think that we kind of haven't internalized that, like, yes, the costs are less, but it's still like a useful tool. And then we talked about this a little bit earlier as well, but a lot of this infrastructure, again, is not part of like the core business offering or the core product for a lot of these companies. Even at Yelp, I built this simulator for Clusterman, and then we switched over from Mesos to Kubernetes, and there
Mm-hmm.
was no space in our planning budget to update the simulator for that switch. And so it just kind
Mm-hmm.
of fell by the wayside.
Do you think maybe it's a little bit like formal methods where if you're, say, you're running a bank and you're really concerned about the way that transactions are occurring, you might
Mm-hmm.
employ TLA plus or something like that? Do you think it's similar with simulation where industries like that, where they really need to get it right, are more likely to try this?
Yeah, I think that's true.
I did think a lot about formal verification when I was reading your ACMQ article and learning about SimCube, and I've been thinking a lot about TLI Plus over the last six months to a year, and so
Mm-hmm.
that occurred to me like, wow, this is a cool tool. I'd love to start using it. It may be an extra sort of thing,
Yes.
not a core, engineering requirement. I'm not actually
Mm-hmm.
delivering something outside of more confidence about what we're doing.
Right.
But it did seem to me that your work, when you wrote about Clusterman and in SimCube as well, there is a direct impact. You could save money by these
Oh,
things,
absolutely.
using these
Yeah.
things. And I imagine the cloud bill for a company like Yelp is astronomical. It must be massive.
Right.
You must be able to save huge amounts of money.
I think a thing that's challenging there is it's difficult, again, partly because of a lack of data and various other reasons. It's difficult to tie a thread to, I made this change to our infrastructure and it saved us X million dollars. Everybody says, yes, I'd love to save money, but really understanding how the changes you make on a day to day impact your cloud spend is pretty challenging.
Wow, that's amazing. So that goes back to that same complexity. We've got this big complex thing. We don't necessarily know what we've done to fix it over the years, and we also
Right.
don't know why it costs us what it costs us.
Right.
That's pretty scary to imagine.
Yes.
I wanted to go back to something you said about what can you take away and still have a valid simulation in terms of data, in terms of input, in terms of
Mhm.
signal. Is there kind of an art? I think you talk about this in the article as well. Is there kind of an art to picking what signal to pay attention to? It's really probably app dependent, or maybe it isn't. Maybe every app shares certain signals that are going to be useful, valid for
Sure.
simulations.
I feel a little like a broken record here, but I'm just going to say it depends. Uh,
Yeah.
for when I was doing this comparison to between cluster autoscaler and Carpenter, I was really interested in a couple of signals, like how quickly do these systems respond and what choices do they make? We talked about like what EC2 instances they decided to spin up. If you were interested more in, let's say you're interested in like a scheduling domain, you're trying to schedule some AI application or something along those lines, a lot of those have really strict requirements on all of our pods need to be scheduled at the same time, or they need to be scheduled on the same network fabric or something like that. And so
Mhm.
in that scenario, you wouldn't care so much necessarily about maybe the response time, but you'd care a lot more about, are these things meeting our scheduling requirements so that the app can be successful. So I think there's a little bit of a art of like, you've been around for a while and you know what signals are valuable, and then also it's just, I think, thinking critically about your application of like, what things does it actually need.
So there's no like silver bullet there. That's
Sadly,
too
no.
bad. I guess I was thinking CPU is probably a pretty common limit for apps. Limit
Hmm.
metaphorically, not necessarily CPU limits, but like it's a constraint that
Right.
every application is probably going to deal with.
I mean, even that, like, yes or no, like some apps, when you have these like complex microservice things, some apps are just sitting idle while they're waiting for the database to respond.
Yeah, that's a fair point.
So most of SimCube is in Rust, but the Kubernetes world is mostly Go. Have there been any challenges in using Rust to do this work?
I've actually been really pleasantly surprised. The Rust ecosystem for Kubernetes is really mature. You mentioned Linkerd earlier. Actually, Linkerd is mostly written in Rust as well. And there are a couple of really solid Rust libraries that I would say have feature parity with like controller runtime or some of these other, really popular Kubernetes libraries. And so I've been really happy working in Rust. The biggest pain point, I would say, is dealing with the verbosity of the Kubernetes API. The API itself has a whole, like, they have all these different fields, and most of them are optional. And in Golang, you can just kind of ignore the optional ones, but Rust really forces you to deal with the none case in every single one
Mm.
of those instances. And so that's been
Mhm.
sort of the biggest challenge. But also, like, in some ways, I think it's good because I've definitely written Golang apps where I've ignored some optional field and then the application has crashed because I shouldn't have ignored it. So,
Is your business model primarily that you use this tool as a consultant, or do you work with companies that are setting this up and deploying it themselves?
currently, I've been using it primarily as a consultant. I would love to have some folks who are interested in setting this up and using it themselves, but I haven't gotten there yet.
I deployed the observability stack for our clusters, and as you can imagine, it's a lot of stuff.
Hmm.
We're using the three pillars of observability. So we've got Prometheus, we've got Grafana, we're using Loki for log aggregation, we're using
Hmm.
OpenTelemetry, and we've got an OpenTelemetry tool that's also from Grafana. It's quite a lot of stuff.
Right.
And my first thought when I saw SimCube was, whoa, it's hard for me to anticipate the footprint of this stuff before I started deploying it, before I
Right.
started thinking about how to manage it. This seems like it'd be a great tool for that. Do you have use cases or particular examples where you think it's a really good fit for people who are working in organizations where they want to know something in advance? They want to predict something and they can potentially use this tool.
Yeah, absolutely. I mean, you can really deploy anything that you want in your simulated environment and see how things respond. I'll go back to the cluster autoscaler carpenter comparison that I did. So one of the things that I did in that simulation was I was able to sort of artificially scale up my simulation by 10 times and then redeploy it in my simulated environment to see how the different autoscalers respond when I'm operating at another order of magnitude. And so I really do think that like being able to sort of predict or run experiments, I guess, is maybe the way I like to think about it. Run experiments about what would happen if suddenly our infrastructure increased by 10 or 100 times tomorrow. Where
Mm-hmm.
would things break? I think that's a really powerful use case.
There's a lot of daemon sets in the monitoring stack I just mentioned. And as a
Hmm.
daemon set, it's like every single node I spin up is going to have one of those things. And as you
Right,
start adding more of those, you're sort of carving out a chunk of the node that's not schedulable. So
right,
that's one area that it seems like it'd be nice to predict in advance to
right.
know what I'm getting myself into, maybe.
Yeah, daemon sets and sidecars both. There are organizations that are running, 10 or 11 different sidecars with every pod they spin up. Again, that's a huge chunk of your compute resources that's kind of getting duplicated. And so being able to reason about what percentage of your infrastructure is being taken up by these things is, I think, really powerful.
I think there's a function sometimes that can happen with Kubernetes orgs that are working with Kubernetes where you see a cool thing and you're kind of in the candy store. In my own case, it was open telemetry. It's like, wow, I've always worked at organizations that if it's a larger organization, they didn't value something like this, they didn't
Hmm.
care, or smaller organizations where there's no ability to build something like this. So when I saw open telemetry, I was like, yes, this is what I want.
Right.
And I'm happy with it. I added it, but there's this feeling of, wow, it's so easy for me to see a thing, service mesh, whatever, and go, oh, cool, let's do that too.
Right.
And that might get me into trouble sometimes. And maybe some of the complexity, the reputation for complexity that Kubernetes environments have is maybe due to that potentially.
I think so.
I'm just guessing here.
That gets back to our earlier conversation around like what do you actually need in your Kubernetes environment, and just use that and don't let anybody do anything else.
I suppose that since it's in the zeitgeist, we have to talk about LLMs.
If we must.
I almost wanted to ask you if I needed a service mesh, but I thought maybe that's too controversial. So we go on to LLMs instead.
So a couple of years ago, when GPT-4 started to be a big deal, I think Eric and I's instinct was immediately, hey, I wonder if we can get this thing to make Helm charts for us. And, there's tools now for trying to do that. We were not super successful with it, but part of the reason I think is because you have to look at these Helm charts and figure out if they're really doing what you want. So is there maybe like a workflow where you can have an AI make you a configuration, deploy it into a simulation environment, test it, see if it's optimal, and then try to steer it in a different direction if it's not working?
Yeah, I've been chatting with folks from a few different companies that are trying to do similar sorts of things. I'll preface this by saying I'm not an AI researcher, or like, I'm not even super up on the technology, but my understanding is that a lot of the more recent AI developments have been around like taking a generic LLM and then trying to do some sort of reinforcement learning with it to try to tailor it or train it in a particular direction. And this is absolutely the sort of thing that SimCube can do. You can spin up a 2,000 node cluster on your laptop or wherever you want, direct your LLM to run all of its kube control commands against that simulated environment. And then I'm not going to say it's easy, but it's easy-ish to know if things are healthy or not. And so you can kind of use that as your reinforcement signal to feed back into the model. So again, I'm not an AI person, but there are a bunch of people that I've been talking to that are really involved in this space who are really kind of excited about this capability.
Yeah, that's interesting. Mike and I have talked in the past about how if LLMs generating code are going to take some of the functionality of some of the functions of what we do at work, you really need that validation piece to
Hmm.
exist. I can't have an LLM generate an app automatically unless we can also validate that that app is working to some
Exactly.
desired specification. And if I
Right.
could do that, then I could sort of have this feedback loop that you described. That sounds pretty attractive. It sounds very interesting.
Yeah. Still very early stages, and it's not totally clear to me that it's going to work, but I do think there's a bunch of promise there.
I like that you said it's not totally clear to me it's going to work. That's how I feel like we're on the same page. We're actually speaking critically
Hmm.
here.
Hmm.
We're not just saying 5 years, all problems are going to be solved.
Right. There's definitely a lot of like hype, and I think that LLMs and sort of the AI field in general, like I try to cut through the hype and understand like what are the real things that are going to be solved and what are just marketing people saying things. And I think
Mhm.
that a lot of the value that we're going to see out of AI, even like before LLMs, a lot of the value that we saw in AI was these like very tailored sort of expert systems where they're really hyper focused on a specific domain, as opposed to these much more generic, like we're going to solve everything kind of approaches.
My guess is that most companies running Kubernetes are doing it in the same way that Eric and I have in the past, which is means some cloud providers manage Kubernetes solution. Are there any difficulties with any of those particular platforms with running SimCube?
Yeah, absolutely. If you look at like Google Cloud or EKS or any of these platforms, they typically limit the sort of data that you can collect on the control plane. That's on some other instance somewhere that you don't have any visibility into, which
Mhm.
makes it a lot more, it's not impossible, but it makes it a lot harder to, sort of collect the simulation data that you need.
I was curious about to go back to your ACMQ article. You mentioned that you were collecting Prometheus metrics at 1 second intervals, and you're
Mhm.
saying I can do this because I know I'm running a simulation. I know there's like a window of time, right? I'm not going to do this forever. I'm not just going to aggregate data forever. But that those Prometheus metrics are, when I looked a little bit at the customized files for SimCube, it looks like it's trying to connect to pulling metrics from like the control plane. Is that mostly where we're trying to get data from to see what is happening at the cluster level? Is that right?
Right, exactly. So again, SimCube doesn't care about what happens at the application level. There's other tools that you can use for that. I really care about like what are all the control plane metrics, like what's controller manager doing, what's the scheduler doing, all of these
Mhm.
sorts of pieces. And to go back to Mike's point, sometimes you can get some of that from the cloud provider, and sometimes you can't.
This is a random aside. I was looking at the SimCube repo, and among the issues, one of the ones you wrote was, we should probably have a Helm chart. And I was like, well, gee, Mike and I have written hundreds of Helm charts. Maybe we should try to do that on the show. We'll just be like, what do you want on your sandwich? You want tomatoes? You want mayonnaise? we'll, just, we'll, we'll just write that right here. But I didn't prepare to do that. So
Yeah, I don't love Helm.
I don't either. I don't either.
Yeah, I, the fact that you have to like pass everything through an indent 6 filter to get the things that you want, it's just like there's got to be a better way to do this.
Yeah, I was actually had a discussion this week with someone at work who hadn't had a lot of experience with Helm charts. She was trying to write an ingress, and
Mm,
she's looping through domains and looping through different services that she wants to feed traffic to and paths and things like that. You can imagine like the nested data structure that you're going to need to build
right.
this. And she's looking at it And her first question is, what is curly brace, dash? Exactly. And I was like, exactly. You start like, yeah. I was like,
Yep.
well, we're using this templating engine in order to dump out YAML. YAML's white space sensitive. And so what that's saying is delete everything up to, delete
Right.
left is what that's saying.
Right.
It's the thing that really frustrates me about that templating language. This is a pretty detour, but it's really, really hard for me to build a mental model of what the YAML's going to look like.
Right.
And that's really all I care about.
Right.
And its error messages suck too. When things
Yeah.
go wrong, it's got these horrible error messages.
Yeah. One of the early projects that I was working on at ACRL is this thing called FireConfig, which was basically trying to solve that problem. It's essentially you're defining your Kubernetes resources in Python code, and then on the back end, like it'll spit out all of the right YAML for you, but the resources themselves, like you can use actual code to reason about them, and then you're not worrying about any of these sort of indentation or white space things. And I feel like there's a bunch of other projects sort of in this vein as well.
Yeah, I've seen various complaints about Helm, and it almost always boils down to this template language is hard to use, and we're generating white space sensitive YAML, and the error messages are really inscrutable frequently.
Right.
And I've seen those complaints a lot, but it continues to be a very popular tool.
Yes. Well, it's so entrenched that it's going to be hard to get away from.
Mm-hmm.
We talked a little bit about the potential difficulties of using the managed systems. I've been experimenting with Google Autopilot recently, and there's some things I like about it and some things that kind of annoy me.
Mm-hmm.
Does a serverless thing like that kind of defeat the purpose of SimCube, or is there still some potential for doing simulations against something like that?
I've also looked into Autopilot a little bit. I don't think it defeats the purpose of SimCube. A lot of the work I've been doing is around autoscaling, but there's tons of other different things that you can simulate as well. I think for Autopilot specifically, as best as I can understand it, they're still just running cluster autoscaler under the hood, and then they're sort of dynamically injecting different node pools into cluster autoscaler. And so, again, I don't work at Google. I have no inside information there, but that's my interpretation of what's happening there. And, that's something that you could simulate if you wanted to.
When I first started using Kubernetes, I guess it would have been about 2018 when I started really deploying it in production. And I am the typical reluctant infrastructure engineer. You could almost see that me coming a mile away. Like, this guy's been building applications for years. He only got into this as a necessary evil, really. I would love to not think about nodes. I would love to not think about virtual machines. I would love to not think about CPU and memory and just say, hey, my app requests this much, and it sort of magically gets gifted that. And there were a little bit of hints about projects maybe moving in this direction, like virtual kubelet. I almost think there was a period of time where Kelsey Hightower was talking about kind of like almost serverless Kubernetes. But I do sort of almost still see that I still want to right size things, and being able to simulate seems like a step forward to being able to right size. If I request 2 CPUs and maybe there's no underlying virtual machine anymore, it's all abstracted away, my app only uses very small amount of CPU. I don't want to be wasteful.
Right.
And I think that's that kind of right sizing problem persists even in this environment. Maybe I'm exaggerating.
Well, I think that gets back to our capacity planning discussion. We talk about serverless and we talk about not worrying about the nodes, but the truth is somebody has to worry about the nodes. These are all running on physical hardware somewhere. And so if you're not worrying about the nodes, how much are you paying to not worry about the nodes? And then the person who's running the nodes, how are they doing their scheduling and their bin packing? So you still somebody has to think about these things somewhere.
That's a very good distillation of serverless in general. How much are you paying to not have to think about that problem?
Right. And maybe that trade-off's totally worth it. In a lot of cases, I think it is.
It's not exactly a question. I wanted to make a comment. First of all, I'd like to encourage our listeners to read David's blog and also his ACM article. And just sort of a meta thing I wanted to say is that you seem to write a lot better than the typical nerd, and which is something we appreciate here at the podcast.
Thanks.
Eric has a literature background, so we really enjoy reading things that are well written in this space. Is that something that you are attempting to do, or are you just naturally gifted, or do you have an editor that helps you out?
I think it's a lot of practice. When you're in a PhD program, you write a lot, and being able to communicate well is something that is really important in this, well, in every industry. But if you can't explain what you're trying to do, then you're never going to be successful doing it or convincing anybody else that it's valuable. So I put a lot of time into writing and giving talks and communicating my work. I do enjoy it. I think it's fun, but I also think it's a really important and often sort of under recognized ability in this industry.
Mhm. When I read your series of blog posts about SimCube, I was like, I want to meet this person. This stuff is great. I feel like I'm grasping what you're saying. You're talking about really abstract, pretty complex stuff, but you're making it groundable for me. You're not leaving me behind as a reader.
Well, thank you. I appreciate that.
So at the end of the ACM article, you sum up, you say simulating distributed systems is not impossible. And actually simulating them can make them easier to use. And I found this to be an encouragement, a charge to act. And I wondered if you have like ways you could encourage people to go out and start thinking about how to simulate other distributed systems, maybe beyond Kubernetes, maybe anything really, any of their apps. I mean,
Sure.
if somebody came to you and said, hey, I want to do more simulation, how would you tell them to get started? What would you suggest that they do?
Sure. I would say start small. Pick a specific question that you have or a specific area of your application that you want to know more about. And maybe this is counterintuitive, but see how much you can learn without simulating anything. And just spend some time like, what data do I have right now? What can I learn from the existing data that I have? You'll probably find that you're missing a bunch of data. And then that's going to tell you, like, oh, this is the area that I need to go and maybe run a simulation or do some more experimentation so that I can collect this data. But definitely, I went through this with Clusterman. I kind of wrote that simulator and then discovered how hard it was to keep up to date with our infrastructure and was like, well, simulation's impossible. Then went through a fairly long arc coming back to Kubernetes and simulation of like, well, this actually isn't impossible. We just need to think about it very carefully. And so if you're trying to do simulation on your own, like the first step is thinking about it very carefully.
It still seems to go back to find the signal,
Mm-hmm.
record the data, get the data,
Right. Yep.
and start there. And from there, then you can think about maybe replaying it, figuring out how to reinterpret it after the fact.
Yep, exactly.
I really liked how you talked about coming out of an operations research background. My old friend and old roommate from college, Babak Farzin, he's been on our show a couple times. He studied operations research. I had never heard of it before I interacted with him. And I'll never forget being in a restaurant one day. We were like in a Denny's. I was with him and one of the people also in his department. And they just started saying, how do we know when we're going to replace the ketchup on the table? It's like, wow, this is a very arcane question. But they were like, what is the most efficient dollar maximized way to think about when someone should walk over here and spend a laborious, slow effort of the time it takes to put more ketchup in the ketchup bottle? But there's a different way of thinking about efficiency, thinking about optimization, thinking about
Right.
the world, the environment that you're in from that background. Do you think that still kind of influences how you approach engineering?
Right. For the OR folks who are listening, there's a really famous aphorism that says all models are wrong, but some of them are useful. So it was originally attributed to George Box. I'm not actually sure that, I think it came from before him, but that's like, I think that really applies when you're thinking about simulation. Is like everything we simulate is going to be incorrect in some way, but hopefully we can get some useful information out of it anyways.
I started out doing simulation stuff in a completely different field, and there's kind of two scenarios I think where people use simulation. One is I want to figure out the properties of something that's way too expensive to build, or I want to figure out the properties of something and I want to do it a million times. Is it sort of the same with software?
I think so, yeah. I want to figure out the behavior of my production 2000 node cluster. I mean, you can't just spin up 2000 nodes to experiment on. And then the flip side of that is I want to understand the behavior of like a million permutations of this system.
My heart goes out to the people who are trying to convince their organizations that they should spend a couple months working on this. Get
Tell them
budget
to talk
for
to me.
it. I will. Well, David Morris, thanks so much for coming on the show today. It was really great talking to you. Really excellent to find out about SimCube. And as Mike mentioned, I have enjoyed reading your writing, and I look forward to more of what you'll be writing about in the future.
Well, thanks so much. It was wonderful to be here and pleasure to meet and chat with both of you.
Thank you.
Well, this has been Picture Me Coding with Eric Aker and Mike Mall. We'll see you again next week.
See you next time.
Bye-bye.